Hello, this is Dong-Soo from the Applied Superconductivity Lab. Today we will learn about the current sharing temperature. This lecture will cover the current sharing temperature by introducing the circuit models for composite superconductors in a two-fluid model. The following circuit models will show the current flowing in the superconductor and matrix layer, depending on the magnet operation. Then we conclude this chapter by mentioning the definition of the current sharing temperature and its region in the composite superconductor. This slide page is a nomenclature for stability chapters, giving variable definitions and descriptions for each technical term. In this lecture, we will mainly use the right column. The circuit models for composite superconductors utilize a two-fluid model, in which the operating current may enter and flow through either matrix or superconductor, depending on the magnet's operation or stability status. When the operating current IOP is less than the critical current IC, the operating current flows through the superconductor without any problems such as resistance or quench. However, when the operating current is more than the critical current, then the current as much as the critical current flows through the superconductor, and the rest of the operating current flows into the matrix. This situation where the current exists in both layers is called current sharing. In addition, as the operating current is more than the critical current, we might think that the magnet is having a quench. However, this current sharing behavior shows that the current is still flowing through the superconductor, even though it has a larger operating current, which indicates that the quench situation has not yet occurred. This situation moment is right before the magnet quenching. More details on the magnet operation analysis will be covered in the later chapters. Next, we introduce more details on the current sharing behavior in composite superconductors regarding temperature change. Below figures show that the critical current decreases as the temperature increases. As the temperature increases within the composite superconductor, there is a particular temperature point where the input current corresponds to the operating current. This specific temperature is called the current sharing temperature, TCS, which indicates the starting point of the current sharing region. The current sharing region is where the current exists in both the superconductor and matrix, and this region is between the current sharing temperature, TCS, and critical temperature, TC. In this lecture, we briefly discuss the magnet stability analysis, as we will have more related lectures in the later chapters. We learned that when the operating current is more than the critical current, the current exists in both the superconductor and matrix. We called this current sharing where the magnet is still operating without quench. The current sharing region is where the current sharing occurs between the current sharing temperature and the critical temperature. One significant takeaway is that above the current sharing temperature, the superconductor may develop resistance and current related to Joule dissipation or heating.